Colby, math.com.
We practiced scientific notation in class today, and on the assignment we're converting numbers from scientific notation into standard form and from standard form into scientific notation, and also doing some practice with integer exponents again. If we look at this first, I want to do 14 and 20 with you. Number 14 is 8 1/10 multiplied by 10 to the negative fifth power. The first thing we should notice is that since we're multiplying by 10 to the negative fifth, that's the same as multiplying by a tenth 5 times or dividing by 10 5 times. And so this will be a very small number when we're done. And the method we learned was to write the first factor, the 8 1/10. And we recognize that it's going to be a very small number, or that we're dividing by 10 5 times. We can just move the decimal 5 places to the left. So make big moves. 1, 2, 3, 4, 5. Make an exaggerated decimal where it lands so that I know the decimal is now here and not here. And then this is just filling in, like filling in an egg carton with eggs. Put zeros in each of these place values. Don't forget that you cannot leave your answer like this. You need to rewrite it to prove that you know where the decimal is now. So 0.0000081 or 81 millionths, and it's good to put the leading zero, the zero in the units digit. Useful, or it's a good practice, especially for science. It's not required. If you didn't put that zero in the units digit, I would still consider it correct. But we have tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, and so this is 81 millionths. This number, number 20, to write it in scientific notation, the first thing we do is copy it exactly as we see it. 0.0002008, which is 2008. I don't even know, 10 millionths here, I guess. But in any case, what you want to do next is you want to think about, where do I need this decimal to be so that my first factor, we learned, we did scientific notation yes or no and why. We learned that the first factor in any scientific notation expression has to be greater than or equal to 1, but less than 10. And so if I move the decimal until I get a number that's greater than or equal to 1 and less than 10, I would move it here, because 2.008 would be greater than 1 and less than 10. And so my first factor in my scientific notation expression is 2 8 thousandths. But if I wanted to move the decimal back to where it originated, I would move that decimal 1, 2, 3, 4 to the left, and so my power of 10 would be 10 to the negative fourth power. And you can sort of check your work without even actually doing anything, just thinking about, if I were now to change this number back into standard form, I can see that I would be moving the decimal 4 left, and so it seems reasonable that I would get the decimal number that we started with. That's just a quick check to make sure you've got the correct sign on your exponent. I also gave you a little bit of practice in the beginning of this assignment with integer exponents and different types of base numbers to see if we recall those rules. And so why don't you try number 4 on your own during the pause, and then come back and see how you did.
Paused.
What we're checking with number 4 is to see whether we understand that this base number is not negative. This is not negative 4 to the fourth power. This is the opposite of positive 4 to the fourth power. So this is the opposite of 4 multiplied by 4 multiplied by 4 multiplied by 4. Or the opposite of 16 squared. And 16 squared is 256. So this is the opposite of 256, which is negative 256. If we incorrectly understood this base to be negative, we would end up with a positive result, but that would be incorrect. So that's just another reminder about how to deal with, how to interpret bases. In order for this base to be -4, the -4 would need to be in parentheses. Okay, I hope that helped with the assignment. I'll see you tomorrow.